Hello friends, welcome to Learning Techniques. This is your host Hemant Gangwar, and in today's video we are going to expand our Terraform understanding to deploy an AWS VPC. In simple words, AWS networking and then some EC2 instances using that. So this is my EC2 dashboard. If we go to the VPC service, we can see only one single VPC, which is a default VPC provided by AWS, is running as of now. So I have written a Git code for you, so we can clone that code and test it. There's a README provided with the code, so I would recommend you guys to have a look over that. Okay, now log into one of our Linux instances. Okay, so let me first clone my repository. Okay, I believe there is one of the directory already present, so let's remove that and then perform our git clone action. Okay, so we're cloning the empty repository over here. So as a first prerequisite step, you need to know that we first have an AWS credentials should be configured in your directory. If you don't know exactly how to do that, kindly refer to my last video. There, I already shown that how you can configure your AWS credentials to use Terraform. So let's switch to the directory, and since it doesn't contain any Terraform structure yet, so it contains several of the files, but no Terraform structure, if you can see. So just run Terraform init over here, and it will download the necessary plugins as per our providers. So we can see it's downloading and installing the HashiCorp AWS plugins. This is the version of the plugin 2.7.0. It may take a few seconds only to do the operation. Okay, so it has done, it is initialized. So if I run the command again, we can see a directory.terraform is created, and if we explore this directory, we can find a provider with a plugin directory, and this plugin is there. So this is exactly what Terraform need to. It just create a provided structure for you so that you can run the commands flawlessly as per the provided provider plugins. Okay, so let's see a few of the components. The main file over here is my network.tf. So let me give a brief overview exactly what we are planning to do over here. It is using a resource structure, AWS VPC, where it's defining the network block which we want to use for our VPC. You can create your own custom as well if you want. Now over the tags here, it's providing the VPC name. Then we are switching to the next section where we are defining the subnets. I have provided 3 subnets over here. You can divide your network into as many subnets if you want. So each subnet is /26, so it's containing around 64 hosts, and I'm providing different subnets, the names, and in which location or which availability zone I'm going to place them. These are the VPC ID, exactly which VPC ID it will take. The thing to note is we don't have to provide the actual name of the VPC. Instead, we use the VPC reference which we use to create. So my AWS VPC is my resource name, then this is the name of the VPC resource, which is primary, and the ID means the ID of the complete ID of this thing. So it's referring that which VPC it will be using. This type of references we will be using a lot in our documentation, so it's a noteworthy point. Then we are creating the different subnets again. The second subnet, it will be placed in South 1B. That will be a development subnet. And the third one is my DB subnet. You can give the name as per your choice. Now, in order to provide the internet connectivity, I'm just creating an internet gateway, providing the reference in which VPC it will lie, and the name of the internet gateway. Now, the next thing will be, since I'm not providing network to all of public access to or internet access to all of my subnets. So for those ones where I'm not planning to take the public IPs, I'm creating an elastic IP and then a NAT gateway. While shooting this video, I'm assuming that you are already versed with the VPC components. If not, you can let me know and I can create a separate video over that. Then we're creating a separate routing tables. One of my routing table will contain a route with an internet gateway so that they can directly access from outside and can use the internet. And another one is using the NAT gateway so that internally it can access the internet. A noteworthy point is inside a VPC, all three subnets will be able to communicate with each other without any issues. Now we have our subnets, we have a routing table, so we're using some resources to bind this type of binding the routing table with a particular subnet. So this is the resource AWS route table association. It's a reference name which I'm using. You can use any name. Then I'm providing the reference of my subnet ID. So my first subnet ID, second subnet ID, and my third subnet ID, and accordingly the routing tables with which I want to connect to. So once the stable binding will be done, we will be adding a service group so that whatever instances I'll be creating will be taking up service group reference. So it is allowing the traffic, SSH or SSH traffic and all ping traffic from anywhere, and it will be binded to my EC2 instances. Now, once my security groups are created, now I'm finally deploying my EC2 instance. So the resource name will be AWS instance, then instance reference, which Terraform will be using, the AMI ID. I'm using a variable for providing my AMI ID. I'll show you exactly. The reference for providing a variable is var dot, and the variable reference exactly what you are using. Then the instance type, it's hard-coded over here like t2.macro, the key name, which key we are planning to use, the availability zone. If you have any other key, do make sure to provide the key name over here, else you may face issues while trying to connect. The availability zone in which I'm planning to launch my instances, the subnet ID which it will be using, and the security group ID which it will be using. Then if I want a public IP over them or not, so on one of the instances, I am looking for a public IP, so I say true. But for the one in which I'm using the NAT gateway, I have asked that I don't need a public IP. So that is the main code which we are referring over here. Then something worthy over here is, first thing is my providers, exactly what provider reference I have totaled over here. So I have clearly told that my Terraform will take these AWS resource section. Then profile will be my default profile, and the region will be my var.region. It's again a variable. So at two places we already defined a variable, so it's worthy to see a variable file. Also any .tf file, any name with .tf extension file will work as a variable file. So I've defined some variables like region. So I have already defined that my region will be AP South 1. Then my variable names, like what will be the name of my EC2 instances, that will take as Terraform AWS Techniques. Then my variable name for my AMI. So I have asked that it will be my AMI and it will be a type of string. Then my security group, default name, instance type, and these are the variable declaration, what type of variable that will takes. So there's one more file with tf extension. So the references used over here will be called file. So my instance ID is this. Here you can substitute your instance ID, the instance type as well. Then that is not required as of now. I was using for some other testing, so we can leave as of now. This is the references which we are using in our code. Then there is one more interesting section which we are looking for, that is my out. So what it will do, it will provide the public IP of one of my instance, then the key name which I'm using over here, then the subnets on which my primary server is attached, and the secondary server private IP, so that we don't have to travel a lot over the GUI to identify the things. Okay, so when the things are in place, so just do a Terraform apply and see if we see any issues. It may take a couple of seconds to create a structure for you. Okay, it has created a structure, though I haven't provided any auto approval, so it's asking me for an option. So if we have a closer look on that, we can see that it's going to perform the create operations. It's going to create a NAT gateway for me. Known after apply means some of the settings, these values will be known once the particular source will be deployed in the AWS cloud. Then it is a EC2 instance reference, whatever details it's going to take, the name which we have provided, the variable it is taking fine. Then another EC2 instance details, then my internal gateway, internet gateway, IGW details, what name it will take, what VPC ID it will take, then my NAT gateway details, my routing table details, what network it will allow or deny, and all those things, and then a routing table association. So I find it all good. It's going to deploy around 17 components. So I'm going to provide a yes, and it will take a couple of minutes to deploy all that stuff, but that will be pretty quick. So we can see it's trying to create an elastic IP, VPC for me, NAT gateway, subnet details, whatever components are required for a network to work. It's all deploying over here. So the best part is you don't need to go to the GUI to do a particular that click, this click, and then waste your time. It's pretty quick. In the end of this video, I'll also let you know about the cleanup, exactly how to do that. One also noteworthy point over here is exactly how much time it will take to create each resource. So you can see it took like 1 minute and so, and while creating the NAT gateway. Okay, so my NAT gateway took the maximum time, and once it's created, it will already created just other components. So as expected, it is also showing me all those values which I put in the out file. So I don't have my key pasted over here, so let me switch to another node where the keys are present and trying to SSH this node. So you can see it's connecting fine. I just gave a mistake that I am trying to connect with the root user. So just let me fix that. So now you can see that it's able to connect to one of my instances which have a public IP. Now regarding the private IP section, it can connect fine from here, but the thing is I don't have the key for that. So I'll get a permission deny message with that. So just let me log out to my original node. Other than SSH, let me do a small SCP. And what I'm going to SCP, let me go over here. Then at which location I want to paste my keys. Okay. It's not a directory for it, so just small reshuffling of parameters, and then the key is copied. So let me connect to the node. It's fine. I can see the key is also present. Now let me try to SSH the private IP using this key. As I'm already logged in through the EC2 user, I don't have to provide that again. And bingo, I'm able to connect with my instance. I can see this is the IP which I'm able to connect. Just to revalidate that the public access is denied for this thing. We can see the ping is not working from outside world. So this is something beautiful which we can see. Now, just to validate the things from the GUI end, let's again move to the GUI section and then see exactly what it has created for me. Now we can see it has created one more custom VPC. If I go to the VPC dashboard, it can show me that it has created 3 other sections. There are several routing tables, internet gateways, one NAT gateway as well, and elastic IP as well. So in the routing table section, if I go, I can see in my main subnet, there is a route attached for the internet gateway. And on the private subnet, there is a route for the NAT gateway. So all things are working as expected. If I go to the EC2 instances, I can clearly see I have 2 EC2 instances running. Both have the name same. You can fix that thing later. Then if you see the instance summary, we can see one of my system has a public IP address and the other one doesn't. So it has deployed the things for me. Now something interesting I want to show you. If you want to make a graph out of this, I recently used an app called Lucid app, which helped me to create a document for it. So we can start with the blank documentation. Then it gives you some of the options by which we can create a graph, a good graph of what we have created as of now. So we are using the AWS service. I'm using the legacy AWS architecture. So it has provided several of the settings. I have tested as of now the AWS CLI script. It is a script which I have already copied to my system inside /root. The script name is test. So, and it is generating one file AWS JSON. Let me first erase that and then run this script. So mistakenly I was just speaking to on my wrong screen. So this is already copied in my root in my system, then the file which I created, and this is a test.py script which I already copied to my system. If I run it here, it will say me that Python is not there in my system. So I'm using the Python environment. So first let me activate a Python in my system. Now it's activated. So let me run a test file. This will execute several parameters and will create a file aws.json for me. Let me copy the component, the content of this file and place it inside a text file in my system or a JSON embedded file on my system. So allow me a minute. And okay. So I have copied inside the file in my desktop section. Let me just use the file to copy that, and this is the file. Okay, I have created a file. I've chosen a file. Let's try to import that and finish and see exactly what it's going to create for us. So you can see it is showing us 2 things. One is the default VPC configuration. We have 3 subnets inside it and nothing is inside any subnet. Then I can see a custom VPC section, which we have created as of now. So if we expand it a bit, we can simply see that we have a custom VPC whose name is custom VPC techniques. Then we have 3 subnets inside each availability zone, AB South 1A, 1C, and 1B, and we have 2 instances inside these. So that's a good option by which you can create a graph for exactly what you're going to deploy. So that's all from my end. But before that, before leaving, I just have one last thing to show you as well. So once you have created every infra with, let's move back to Terraform. You don't need to go and remove everything. That have a hassle that it can be neglected, or some components can be ignored, which may incur you several charges. So we are using NAT gateways, so there's a disclaimer that you may have faced some additional charges because flowing any traffic through NAT gateway causes a small charge. It's chargeable. So okay, let's first finally move. Let's first destroy everything. So Terraform destroys the command, and I'll give auto approve so that it won't ask me anything. So we can see it silently destroying each and every component which we have created effortlessly. So if you're planning for any testing, it's a best tool, and the script description I'll give in the notes section, and also the GitHub page. So it will be pretty quick for you to just create an environment and destroy everything. If we go to our AWS section again, we can see that everything is already wiped out. So regarding these AWS EC2 instances, they are deleted. They must be internet section. And if I go to my VPC section, I again have only one. Though this NAT gateway is visible, but it is also in deleted state, so it will be clean soon. So that's all from my end on this video. If you actually like my work, do share with your friends. So thank you very much.